class. Right. So today's class is about a fresh topic, fresh subject. It's all about biomedical instrumentation. So biomedical instrumentation is one of the important core subject, especially not only for GATE. As a biomedical engineers, if you don't know biomedical instrumentation, if you fail to understand the concepts in biomedical instrumentation, definitely the survival is very difficult in your biomedical. If you start your career as biomedical service engineer or manufacturing side, whatever you go, so definitely a single 2-mark question which you study in uh, your syllabus or in your GATE preparation, it matters a lot. It plays a important role when you start your career. So there you will definitely feel if your preparation is good, if your learning process is good, definitely half of the job is done. Okay, and appearing for interview again. So biomedical instrumentation preparation is more predominantly uh, subject comparing to other subjects. So we'll again for GATE, yes, they give more importance to biomedical instruments. Lot of questions, lot of easy questions, lot of moderate questions, even very few hard questions. So there may be that in 2022 there may be the same. They'll give a equivalent weightage to biomedical instrumentation. Fine. So with that, we'll start with. Uh, Today's class is all about biopotential, origin of biopotential, action potential, and we're going to discuss about few numericals about all those things, and at last we'll end up in electrodes, right? So this is what today's agenda for biomedical instrumentation class today. Fine. I have shown you some sort of molecules in your screen. Can anyone guess what this molecule is? See, from this month, I need some more interaction from new faces. Definitely, these topics today, this entire month, all the topics are already you have studied at least once in a lifetime. You have studied. So, what is biopotential, action potential, and all you keep on studying it from your +2. So +2 anatomy. அதுக்கப்புறம் வந்து you have studied in pathology, you have studied in biomedical instrumentation, now radiological equipments, DTE. Almost 5-6 subjects you are studying the same concept repeatedly. So the same way for other subjects also. So imaging, medical imaging, yes, some few third years are there, so you may not have gone through radiological equipments. But so this month, all the topics we are familiarized with. So I need all your cooperation and all your interaction. So then only I can make class more interesting. If there was no interaction from your side, obviously from my side also I'll go in a different path. So I don't want to make you trouble also. So kindly be interactive. So all our forum peoples, those who are there in our class or our friends, so any some various colleges like namla mari biomedical students. So please be interactive. So before I start this month, I insist this, please be interactive. If you are not interactive, definitely I'll change my approach without informing. Okay, so please be interactive. Okay, so I have shown some sort of molecules in your screen. Actually, what is? Can anyone guess what is this?
Sir, potassium ion channels, potassium.
Who is that?
Lingadarni, sir.
Yes, potassium channels. Okay, exactly. Answer is right. So the given molecule is potassium ion channel. How you guessed? Lingadarni, how you guessed this is potassium? Any specific either, or you have guessed it, or whether you have?
சார்
Okay,
எங்க
gone
இது ஆல்ரெடி படிச்சிருக்க மாதிரி இருக்கு சார். எங்கேயோ ரெஃபரன்ஸ் புக்ஸ் மேம் சென்ட் பண்ணும்போது ஸோ அதுல இருந்து டயக்ராம் படிச்ச ஒரு ஞாபகம், ஒரு கெஸ்ட் தான் சார்.
super, very good. So you have guessed it correct. It is a potassium ion channel. So here there is a single potassium ions. So it will be covered by different covalent molecules. Okay, so it will not allow the potassium to go out of this channel. Okay, so whenever there was opening, so whenever this gates open, so this molecule gate will open at some period of time when we give stimulus something else. So during that time this potassium ion will pass through, so it will go out of the cell, right? So this is potassium ion. So fine, next is, yeah,
Sir.
cell. Yes, who is that?
Sir, Veeresh.
Yeah, Veeresh, any doubts?
Sir, may I know what are the red and blue color ions present in there?
Yeah, blue color is what potassium is, and the red color is for sodium, and gray is for chlorine, right?
Thank you, sir. Yes, sir. Thank you.
And this is for just for 3D dimensional, just for our visualization, but in your real cell the ion channel will be different. So just for our identification they have given a molecule like this, but in a real cell it will be a different scenario. Okay, cell, definitely cell is integrated part of origin of biopotential we have in our syllabus. So you should be able to understand cell, and you should be able to understand anatomy. Okay, so you should study what mitochondria is, what is extracellular, what is intracellular. We have carbohydrates, and we have ribosomes, we have cholesterol, we have various components of cell. So there may be the question paper setters, they attempt to take some at least 1-2 questions from cell. Okay, so it happens in future also, so kindly aware of all the internal components of human cell and its function. So they'll ask you function and they'll give you some 4 options. So which of these following will involved in the given function, like that, or they'll give any particular cell like ribosome or mitochondria, they'll ask you what function it do. So vice versa. Okay, so anatomy of cell you should be ready to study. So you should study anatomy of cell a lot. Okay, so actually cell is a complex structure, so it's very hard to understand cell. Okay, so because it have a lot of components in it, each component helps us to do some lot of works. So yes, complexity is lot, and today we're going to look into the physiology of cell membrane. So this is cell membrane. So what physiology the cell membrane is going to call, and how cell in cell membrane, how it is moving, how it is transporting ions, what is inside, right? So this is extracellular, this is intracellular. So what is inside, what is outside the cell, what is inside the cell, what ions are greater in extracellular fluid. So இது எல்லாமே வந்து இன்னைக்கு கிளாஸ்ல வந்து we going to cover. So எப்படி இது டிரான்ஸ்போர்ட் ஆகுது, எதை வச்சு டிரான்ஸ்போர்ட் ஆகுது ions. So definitely you'll have detailed information on cell membrane, right? So I have shown you some 3 pictures. You can take this as first picture, this is second, this is third. Okay, so understanding these 3 pictures will make my job easy. So இது ஓரளவுக்கு புரிஞ்சுக்கிட்டீங்கனாலே இன்னைக்கு கிளாஸ் வந்து நமக்கு it was off the way done. Okay, so that's why I came to display these 3 pictures. So what is picture 1?
Sir, stop signal.
Yeah, it is stop signal. Okay, So this happens in India. So stop signals in India, there will be a traffic constable. If they show you a stop signal, all the vehicles will stop, and I can walk through. Okay, so the persons standing here can walk through some roads, and after we walk through, they'll open it, and the vehicles will move. Okay, right. So this is stop signal. So யாராவது ஒருத்தர் ஸ்டாப் காமிச்சா அதுக்கப்புறம் நம்மளோட வாக்கிங் ப்ராசஸை நம்ம ஸ்டார்ட் பண்ணணும். ஓகே, what is picture number 2? Those who are curious with US, you may answer this, because in US and all we don't have speed breakers, we don't have traffic constables every 3-4 kilometer once. Yeah, it's not like that. So that is, they have a different traffic rules. What is this?
If we push that
Pedestrian
button,
crossing, sir.
it will.
Yes, what is that?
Sir, once we push that button, we can select that. It will. It is like a stop signal, but we have to push that button. So after that only we'll get to cross the road.
Okay, super. Who is that actually? Can't able to
Shweta,
you.
sir.
Yeah, Shweta. Yes, yeah, Shweta from CA. Fine. Exactly, it's that correct. So when you push this button, if I want to cross the road, okay, so you have to press do not cross. So immediately there will be some blockings over there. So all the cars will line up. So they will give some space to cross. So we can cross the road. So after we get crossing, it will automatically opens up. So here also, so when I give some push button, or when I give some intimation, they'll ask us to move. Okay. So third image, we all know that, right? So what is third image? It is accelerator. How the person moving happens here. So here you need to spend some energy to move. When I put a stop, you have to cross the road by spending some energy. Here the same thing. So when vehicle stops, you have to spend some energy and you have to move. What about accelerator?
So no need of energy, sir.
Yes, no need of energy, and it's no one will stops you, right? So it will keep on, it's moving. So simply you can go and you can travel. So simply without any disturbances you can travel, and from moving from one place to another place, you don't need to spend some energy. Okay, no energy needed. So simply you stand, this accelerator will make you free and it will take you to the different place. Okay, so here first two category is different and third category is different. So this is what we going to discuss in cell. Okay, so we have two transport. You can say like இங்க எப்படி நம்ம வந்து ஒரு person சொல்றோமோ, எப்படி வந்து ஒரு person move பண்ணனும், ஒரு person வந்து we need to travel, இங்க வந்து ஒரு person can stand, that accelerator will take you. The same thing, you can visualize it for ions. Either it can be sodium, potassium or calcium. So if you have ions, நம்ம செல்லுல வந்து பாத்தீங்கன்னா we have ions. So the ions will transport. So the transport happens. Okay, so there are two different way to transport ions. The ions வந்து intracellularக்கும் extracellularக்கும் move ஆகும். So அப்படி move ஆகும்போது there are two different classification of movement. One is passive and second one is active. Right? So can anyone give me what is passive transport, what is active transport? And you can relate with these three pictures. So which picture is active, which picture is passive?
Active means we need energy, sir. So first two is obviously active, and
Active transport, first two, as you said, first two pictures are
I think the first one is an osmosis like that due to
Exactly.
osmotic potential.
Super, very good. So you have gone one step ahead and you make my job easy. Fine. Active அப்படின்னா you no need of energy. Sorry, active you need energy, right?
Yes, sir.
Yes, sir.
Sorry. So whether 1 and 2 is active or passive, you need some energy to uh, cross the road. Yeah. So active transport, you need some energy. Where you get this energy in a human cell?
Mitochondria, sir. ATP.
Yeah, mitochondria. ATP. What is ATP? Adenotriphosphates. So you get from mitochondria. Okay, in a cell, mitochondria gives ATP energy. So with the help of energy, the ion transport happens in the active way. Okay. If stops, you need to walk. You need to cross the road. You have to spend some energy and you need to cross the road. So that is active transport. Okay. But signals la nama cross pandrathu active transport. You can relate them. So third picture is passive. No energy needed. Purida. So no energy needed. You simply go and stand. Your accelerator will take care of you, and it can carry to the different location. Just stand in accelerator, it moves. No need to spend the energy. Doesn't require cell to spend any energy to transport. Okay. So in our cell, we have two different types of energy. One is active transport, passive transport. So fine. We'll discuss each one of. So before that, you should understand the physiology of ion transport, or we used to call technically we used to call membrane potential. So which is one of the most important concept to understand. If you don't understand this, it's very tough to understand the rest of the entire class. So numericals and other things. So kindly be attentive and listen. Okay, membrane potential apna, it's nothing but we have some cell-kulla வந்து we have cell membrane. So a cell membrane la, so we have two different segments. One is extracellular, another one is intracellular. Okay, there will be a small gap between this, that is called a cell membrane. So between intracellular and extracellular, we have cell membrane. Okay, so fine. So in extracellular, there is a ion concentration gradient. So we have some ions. Okay, நம்மளோட ஒவ்வொரு செல்லுல உள்ள வந்து பாத்தீங்கன்னா ஒரு அயன் கண்டென்ட் இருக்கும். Fine. Okay, if you take extracellular, என்னென்னலாம் சார் அயன் கண்டென்ட் இருக்கும் அப்படின்னா, we have lot of ions. In that predominantly மூணு அயன் சேனல்ஸ் அயன்ஸ் வந்து நமக்கு வந்து மேண்டட்டரியா தெரியும். ஒன்னு வந்து பாத்தீங்கன்னா sodium. Sodium is denoted as Na+. This is sodium. Okay, next is K+. What is K+? What is K+?
Potassium.
Potassium.
Yeah. Potassium. Okay. What is Cl-? Chloride, right? So we have three ions. 1, 2, 3, which is predominant, which is in numbers, if we count, it is more. But apart from that, we have other ions. We have phosphate. We have other ions. யாரா சொல்ல முடியுமா? இன்னும் இது தவிர என்ன வேற என்ன ions இருக்குன்னு forgot it. So we have calcium. We have இல்லையா? So அது மாதிரி நிறைய ions இருக்கு. So in that, most important thing is these three. So these three are more important. Okay. இப்போ we have extracellular, intracellular. இப்போ எதுல சார் அதிகமா இருக்கும்? சோடியம் எதுல அதிகமா இருக்கும்? பொட்டாசியம். எந்த கிரேடியன்ட் கான்சென்ட்ரேஷன், அயான் கான்சென்ட்ரேஷன் கிரேடியன்ட்ஸ் எதுல அதிகமா இருக்கும் அப்படின்னா, sodium is higher at extracellular fluid. If you see the a triangle denotes, the blue color part denotes which is higher concentration. So when it goes short, so this side we have very limited components. Same way K and Cl- also. Okay. If you take sodium, it is higher in extracellular fluid. Okay, so this side we have lot of sodium. Okay, we have different lot of sodium compared to other ions. The same way, if we take potassium எடுத்துக்கிட்டீங்கன்னா intracellular fluid it will have a more potassium. Okay, we have more potassium, lesser sodium. Sodium இருக்காதா அப்படின்னா definitely there will be sodium, but very limited in numbers. If you take chloride, yes, it's in extracellular fluid. It's higher in extracellular. It's very limited in intracellular. So intracellular dominant ions வந்து ஒண்ணுதான், which is your potassium. But in extracellular you have two ions, your sodium and chloride. Any doubts now? As far as class is concerned, any doubts?
No, sir.
No, fine, thank you. So இப்போ எவ்வளவு சார் இருக்கும், எவ்வளவு அயன் கண்டென்ட் இருக்கும் அப்படின்னா, in extracellular fluid the sodium content is most probably 142 ions are there. If you take chloride, it have 103 ions. Same way in intracellular fluid, if you take potassium, you have around 140 ions. Same way in intracellular fluid, we have sodium, but it's very less. Most probably like we have 10, and calcium we have only 4. So this is in numbers. Same way in extracellular fluid, we have potassium in 4 in numbers. So if you see the count, Na plus and Cl have more numbers in extracellular, and potassium have more numbers in intracellular. Fine. So outside, you can say extracellular. In some books, they'll refer outside the cell. So outside is nothing but extracellular. Inside is intracellular. So they'll refer, in different books, they'll refer different terminologies, but both are same. Okay. So இப்போ இது எப்ப சார் இது மாதிரி இருக்கும்? எப்ப எக்ஸ்ட்ராசெல்லுலர்ல it will have more ions, intracellular more ions? எப்ப இது நடக்கும்? When there is more ions in extracellular, intracellular. இந்த picture எப்ப நடக்கும் actually? When your cell will have this particular picture. When cell it at rest, right?
Resting
Yes, sir.
stage, sir.
Yes. At resting stage, you will have this scenario. So extracellular எவ்வளவு அதிகமா இருக்கு, intracellular எவ்வளவு இருக்கு. எப்போனா ரெஸ்டிங் ஸ்டேட். ஒரு செல் வந்து நீங்க எந்த விதமான எக்ஸைட்டேஷன் கொடுக்கல, ஸ்டிமுலஸ் கொடுக்கல அப்படின்னா யுவர் செல் வில் பி அட் ரெஸ்டிங் ஸ்டேட். ஓகே. ஸோ ரெஸ்டிங் ஸ்டேட்ல இது மாதிரி வந்து ஒரு ஃபார் எக்ஸாம்பிள், ஸோ ரெஸ்டிங் ஸ்டேட்டுக்கும் ஸ்டிமுலேட்டட் ஸ்டேட்டுக்கும் என்ன சார் டிஃபரன்ஸ் அப்படின்னா நிறைய ஸ்டூடெண்ட்ஸ் கேட்பாங்க. ஸோ ஓகே சார், ரெஸ்டிங் ஸ்டேட் ஓகே, ஸ்டிமுலஸ்ன்றீங்களா அப்படின்னா என்ன சார், எப்படி வந்து ஒரு செல்லு ஸ்டிமுலஸ் கொடுப்பீங்க? ஓகே ஃபைன், யூ டேக் இசிஜி. ஓகே, இசிஜி எடுக்கிறோம். இசிஜி அப்ப நம்ம வந்து எலக்ட்ரோட்ஸ் பிளேஸ் பண்றோம் இல்லையா? யூ பிளேஸ் எலக்ட்ரோட் இன் செஸ்ட் எலக்ட்ரோட்ஸ், வி ஹேவ் ரைட் ஆர்ம், லெஃப்ட் ஆர்ம் அண்ட் ஆல். ஸோ டூரிங் தட் டைம் நீங்க அந்த எலக்ட்ரோட்ஸ் வைக்கிறீங்க இல்லையா, அந்த எலக்ட்ரோட்ஸ்ல இருந்து தட் எலக்ட்ரோட் வில் மேக் யுவர் செல் டு ஸ்டிமுலஸ். ஓகே, அப்போ இந்த அயன் டிரான்ஸ்போர்ட் நடக்கும் போது எவ்வளோ எலக்ட்ரிக்கல் ஆக்டிவிட்டி அந்த மசில்ல இருக்கு அப்படின்றத ரெக்கார்ட் பண்ணும். ஹார்ட் அப்படின்னா, ஸோ இப்போ இந்த அயான் டிரான்ஸ்போர்ட் வந்து ஹார்ட்ல நடக்கணும். அப்ப நடக்கிறதுக்கு அந்த எலக்ட்ரோட் வந்து இட் வில் ஸ்டிமுலேட் யுவர் ஹார்ட் மசில். ஓகே, ஸோ டூரிங் தட் டைம் யுவர் அயான் எக்ஸ்சேஞ்ச் ஹேப்பன்ஸ். The same way for EEG, EMG, EOG, whatever the. That's why we study biopotential. It is very basic. Okay, so they expect more questions from numbering potential in GATE. Fine. At rest, there is excess sodium and chloride in extracellular and potassium at intracellular. Fine. So, எவ்வளவு சார் voltage at resting potential? Okay, resting state la the voltage of inside the cell எவ்வளவு இருக்கும் அப்படின்னா will have -70 millivolt. This is important number to remember, to recall. Okay, your intracellular, it is intracellular voltage. Intracellular voltage is -70 millivolt. Extracellular voltage will be 0. We'll have this as a reference. So that's why we place right legல reference ஏன் வைக்கிறோம் அப்படின்னா அந்த இடத்துல உங்களுக்கு ஸ்டிமுலஸே நீங்க என்ன கொடுத்தாலும் வராது. So that's why you refer that electrode as 0. Okay, so extracellular voltage as 0. So intracellular voltage is minus 70 millivolt. Fine. Okay. So here there was some openings, right, in cell membrane. So these are all the compact cell membrane. We have been there was some bridge between your intracellular and extracellular, but so there was some openings here. What is this gate called, or what is this opening called?
Sodium potassium gate, sir.
Yes, sodium potassium gate. Here for this picture, you can relate with color and tell me. You can relate with ions color. It's violet color. Something else like what?
Potassium pumps.
Yes.
Potassium gate.
Yes, it is potassium gate, or we used to say potassium pump. Okay, if it is potassium pump, this pump or this gate will allow only potassium. நீங்க வந்து இங்க chloride இல்ல வந்து if you have sodium and all, it won't allow inside. Okay, it is a charged particle. It will allow only potassium. The same way we have a pump for sodium and chloride. So we have sodium pump, we have a chloride pump. Okay, so when it open up, your potassium ions will move from intracellular to extracellular. The transport happens only when it opens. Epo open agum, when you give stimulus it opens, otherwise it will close. It will at rest state, your all other ion contents are remain same. Okay, it will open when there is a excitation happens, right? We'll discuss when cell gets excited, how it gets excited, and if it excited, what happens. Okay, right. When cell gets excited, okay, if I going to excite some cell, I going to give some stimulus through an electrode, and I going to excite in the mari or resting state la irukra cell I going to excite. What happens first thing, there will be a first transport. First ion transport is what ions will move? First transport.
Sodium.
Yes, exactly. So first sodium ions will move. So from where to where it is moving from? We have more sodium in extracellular. So in extracellular இருக்க நிறைய சோடியம் இருக்கிறதுனால அது ஒரு ஈக்குவலிபிரியம் கண்டிஷன் வரதுக்கு ட்ரை பண்ணும். உன்னோட செல் வந்து எக்ஸஸா இருக்கு, இங்க வந்து சோடியம் எக்ஸஸா இருக்கு, இங்க பொட்டாசியம் எக்ஸஸா இருக்கு. ஸோ அதை ரெண்டும் ஈக்குவலா ஆக்கிறதுக்கு ட்ரை பண்ணும் நீங்க ஸ்டிமுலஸ் கொடுத்ததுக்கு அப்போ அது என்ன ஆகும்? ஃபர்ஸ்ட் கண்டிஷன் என்னன்னா, யுவர் sodium ions moves from extracellular to intracellular. Your sodium moves from there will be a gate. Sodium gate opens up. It will allow the sodium to move from extracellular to intracellular. எவ்வளவு சார் மூவ் ஆகும் அப்படின்னா, for example, we have 142 sodiums here and only we have 10 sodiums here. So almost 70-75 sodiums will move from extracellular to intracellular cell to make it equilibrium. Okay, so in our nature you can think, so it's a natural beauty. So எல்லாமே வந்து automatic process, synaptic process. No one will it is not a closed loop, or no feedback is controlled. So all things happens in a real as usual, like cell stimulus anone automatically the transport on the equilibrium core. Okay, so this transport is called as influx. We used to call as influx. To sodium pump, the transport happens. Okay, next process ennago, once inga irukra sodium ella inga move aayichu, so rendu side equal ah. Next is the potassium pump opens up. So indha mari potassium pump opens up, the potassium ions will transport, so from intracellular to extracellular. This is called as efflux. EFFULX. Okay, efflux, that is influx, that is efflux. Efflux is nothing but E means extracellular. உன்னோட potassium intra la irundhu extra வருது, that's why it is E. இங்க வந்து எக்ஸ்ட்ரால இருந்து இன்ட்ராக்கு போகுது. எங்க டெசிக்னேஷன் போதோ அதை வச்சு இன்ஃப்ளெக்ஸ் எஃப்ளெக்ஸ் அப்படின்னு சொல்றாங்க. ஸோ தேர் மே பி அ கொஸ்டின் லைக், ஸோ இன் இன்ஃப்ளெக்ஸ் வாட் ஹேப்பன்ஸ், எஃப்ளெக்ஸ் வாட் ஹேப்பன்ஸ் and that. Okay, you should be remembered. So potassium pump opens, so there will be a transport of potassium from intracellular to extracellular. Okay, இப்போ ரெண்டு சைடும் ஈக்குவல் கண்டிஷனுக்கு வந்துருச்சு. Okay, so now I stop giving stimulus. What happens? What is this third stage? I stop giving stimulus. What happens?
Repolarization stage, sir.
Like, so we'll name it afterwards. Okay, what transport happens? இப்போ வந்து இன்ட்ரா செல்லர்ல இருந்து அங்க போச்சு, எக்ஸ்ட்ரா செல்லர்ல இருந்து உள்ள வந்துச்சு. ஸோ ஈக்குவலிபிரியமா இருக்கு, ரெண்டு சைட்லயும் Na பிளஸ் கால்சியம் எல்லாம் ஈக்குவலா இருக்கு. ஸோ இப்போ நான் வந்து ஸ்டிமுலஸ் ஸ்டாப் பண்ணிட்டேன். ஓகே, வாட் ஹேப்பன்ஸ்? Again it will come back to original state or அங்கே ஸ்டே ஆயிருமா?
So again it comes back to original state.
ஸோ இங்க இருந்து Na பிளஸ் இந்த பக்கம் போயிட்டான், இந்த பக்கம் வந்து பொட்டாசியம் இந்த பக்கம் போயிட்டான். ஸ்டிமுலஸ் ஸ்டாப் பண்ணீங்கன்னா என்ன பண்ணுவான்னா, அவன் வந்து அங்கேயே தங்கிட மாட்டான், அவன் வீட்டுக்கு வந்து வந்துருவான். சரிங்களா? ஸ்டிமுலஸ் கொடுக்குற வரைக்கும் தான் அவன் வந்து அந்தந்த வேற ஒரு விருந்தாளி வீட்டுல இருப்பான். அதுக்கப்புறம் அவனோட ஒரிஜினல் ஸ்டேட்டுக்கு வந்துருவான். ஒரிஜினல் இன்ட்ராசெல்லுலர் பீரியடுக்கு வந்து பொட்டாசியமும் சோடியம் வந்து எக்ஸ்ட்ரா செல்லுலர் பீரியடுக்கும் வந்து ஆட்டோமேட்டிக்கா வந்துடும். அதை தான் நம்ம வந்து ஆக்டிவ் டிரான்ஸ்போர்ட்னு சொல்றோம். தேர்ட் ப்ராசஸ் நமக்கு நடக்கும். ஸோ இப்போ ஃபர்ஸ்ட் ப்ராசஸ் என்ன? ஸோ ஃபர்ஸ்ட் ப்ராசஸ் இஸ் யுவர் Na plus ions. Na plus ions it transmit from extra to intra. So this is called as influx. Used called as influx, and through it happens through potassium pump. Okay, so first in the process வந்து we name it depolarization. So this இது depolarization repolarizationலாம் தெரியலன்னா டெஃபினெட்லி இசிஜி சுத்தமா புரியாது. So there you come across like QRS is ventricular depolarization, ST is ventricular repolarization, என்னென்னமோ சொல்லுவாங்க. ஸோ டீபோலரைசேஷனா என்னன்னு தெரியாம தயவு செஞ்சு இசிஜி சிக்னலை யூ cannot understand. Okay, so kindly make sure that depolarization is first process happens. First depolarize தான் நடக்கும். Okay, you can easily remember. Okay, எப்படி நான் சொல்றேன்? So first process Na plus ions வந்து extra to intra, it is called as influx, and through Na pump it is called as depolarization. Okay, second is we used to call as same way it happens for like potassium, right? So potassium ions, A plus ions moves from intra to extracellular fluid. So this process is called as flex. This happens to potassium pump. First process depolarization. So what is this process called as? Depolarize happens. Once depolarized, cell will again repolarize. So this is called as repolarization. எப்படி சார் நான் ஞாபகம் வச்சுக்கிறது? எப்பவுமே ஒரு செல்லுல ஃபர்ஸ்ட் அது வந்து இப்போ இதை வச்சுக்கோங்களேன், இப்போ இது வந்து ரெஸ்டிங் ஸ்டேட்ல இருக்கு. சரியா? ஸோ ரெஸ்டிங் ஸ்டேட்ல இருக்கும் போது அங்கங்க அவன் அந்தந்த வீட்டுல இருக்கான். இப்போ இதை வந்து நீ டீபோலரைஸ் பண்ற, அதை வந்து ஒரு டிஸ்டர்ப் பண்ற. சரிங்களா? ஒரு டிஸ்டர்பன்ஸ் பண்ணும்போது அதுதான் நம்ம வந்து டீபோலரைசேஷன். யூ கேன் ரிமெம்பர், டீபோலரைஸ் இஸ் ஃபர்ஸ்ட் யூ டீபோலரைஸ். ஒரு அயான்ஸ் வந்து நீ ஸ்டிமுலஸ் கொடுத்தோடனே Na plus அயான்ஸ் போகும், அது டீபோலரைசேஷன். Again Na plus போனோடனே potassium will move on, so that is called as re. இங்க depolarize ஆயிடுச்சு. Obviously if depolarization happens, again repolarization will continue. So this is the continual process where potassium ions will move on. Okay, so this process is called as repolarization, a flex process, intra to extra through a potassium pump. Potassium pump It will transport only potassium. If sodium tries to enter into a potassium, it won't allow you. It won't allow the cell membrane to transport sodium in potassium gate. So in a cell membrane, we have 3 gates. So this is sodium gate, this is potassium gate. So only the orange color, which is sodium, will move here. Okay. Yellow color, which is potassium, will move from extracellular to intracellular through the gateway. Right? Fine. So third process happens is, this is called as active transport. Obviously அவன் அங்க போய் செட்டில் ஆயிட்டான். ஆப்வியஸ்லி அங்க இருந்து மறுபடியும் அவன் திருப்பி அவன் இடத்துக்கு வரணும், ரெஸ்டிங் ஸ்டேட்டுக்கு வரணும். ஸோ ஆக்டிவ் டிரான்ஸ்போர்ட் நடக்கும். இப்போ என்ன ஆகும்னா, போத் K பிளஸ் sodium and potassium ions moves. எதை வச்சு மூவ் ஆகும் அப்படின்னா, we have sodium potassium pump. So in the pump வந்து it will enter, it will allow both sodium and potassium. See, this pump is called as sodium and potassium pump. இங்க பாத்தீங்கன்னா ஆரஞ்சு கலர்ல சோடியமும் வருது, எல்லோ கலர்ல பொட்டாசியமும் டிரான்ஸ்போர்ட் ஆகுது. சரியா? சோ அப்போ இது ஈக்குவலிபிரியம் கண்டிஷன்ல இருந்து மறுபடியும் வந்து அவன் வந்து எக்ஸஸா எங்க இருக்கானோ அங்க போய் செட்டில் ஆகும். Okay, so this happens through sodium potassium pump. This is called as active transport. This is influx, this is efflux. Sorry, some disturbances. This is active transport. For active transport to happen, we need some energy. This is called as ATP. Through mitochondria, we need some energy to make this transport possible. Without ATP energy, active transport doesn't happen. Okay, fine. So this phase is called as refractory period. Refractory period na மறுபடியும் அவன் போய் அங்கங்க செட்டில் ஆகுறது தான் refractory period. ஓகே, இந்த refractory periodல அதாவது வந்து செல் வந்து உங்களுக்கு ஸ்டிமுலஸ் கொடுக்குறீங்க, எக்ஸ்ட்ரா செல்லுலர் இருந்து இன்ட்ரா செல்லுலர் போது அங்க இருந்து மாறுது. இப்ப ரிஃப்ராக்டரி பீரியடுக்கு அவன் வந்து அவனோட ஒரிஜினல் பிளேஸ்ல போய் செட்டில் ஆகிறதுக்கு இங்க இருந்து டிரான்ஸ்போர்ட் நடந்துட்டு இருக்கு. அப்போ இந்த ரிஃப்ராக்டரி பீரியட் அப்போ இஃப் யூ கிவ் அ ஸ்ட்ராங் ஸ்டிமுலஸ், ஒரு எலக்ட்ரோட் வச்சோ இல்ல வந்து ஒரு எலக்ட்ரிக் ஷாக் வச்சோ, you are trying to give a strong stimulus, what happens to cell? Whether your cell responds or not, it will respond or not. If you give a stimulus during this refractory period, what happens? Whether cell respond or not?
Sir, actually, they does both, sir. Absolute, there is 2 types in this refractive period, sir.
Generally, like refractory period, what happens? You can say absolute, yes, absolute, what happens? And
they do not respond, sir.
Yes. Refractory period will not respond. என்னதான் ஸ்டிமுலஸ் கொடுத்தாலும் உன்னோட செல் ரெஸ்பாண்ட் பண்ணாது. ஏன் அப்படின்னா ஆல்ரெடி இங்க டிரான்ஸ்போர்ட் நடந்துட்டு இருக்கு. சோடியமும் பொட்டாசியமும் இங்க இருந்து வெளியில இருந்து உள்ள வந்து ஒரிஜினல் அந்த ஈக்குவலிபிரியம்ல இருந்து நார்மல் கண்டிஷனுக்கு போயிட்டு இருக்கும் போது நீங்க என்ன ஸ்டிமுலஸ் கொடுத்தாலும் உங்க செல் வந்து ரெஸ்பாண்ட் பண்ணாது. சரிங்களா? அதுதான் நம்ம வந்து we used to call as refractory period. Okay, can you follow me up to now? Any doubt? Any doubts?
No, sir.
Fine. So this is action potential curve. So we have studied what is depolarization, repolarization, resting potential. So this stage is called as refractory period. Okay. So depolarization happens at minus 70 millivolt. Okay, so at resting state, so your cell will be at resting state. So your intracellular fluid will have more potassium, extracellular fluid will have more sodium and chloride. So during that stage, you will have a lag fill. So there is no transport happens. Okay, so when it reaches around minus 55, minus 55 millivolt. Minus 55 millivolt. You should remember this. The minimum millivolt, minimum current required to activate your cell is minus 55. There may be a question from this part. So minimum energy, அதாவது ஒரு செல்லை வந்து ஸ்டிமுலேட் பண்றதுக்கு நீ அந்த டிரான்ஸ்போர்ட்டை நடக்க வைக்கிறதுக்கு மினிமம் மைனஸ் 55 மில்லிவோல்ட் எனக்கு வேணும். ஓகே, minus 55 ஓட less than minus 55 கொடுத்தீங்கன்னா அந்த டீபோலரைசேஷன் நடக்காது. So once it reaches minus 55, your ion transport happens. Okay, the first process happens. So Na plus will move from outside to inside. That is called as depolarization. Once it reaches 35, it can go till 40. So in the curve one, it can go till 40. But a normal range of repolarization to happen is plus 30 for repolarization. Okay, so plus 30 millivolt. When it reaches, repolarization phase starts. So in repolarization phase, K plus ions will move. Here, sodium ions will move. Okay, and refractory period. So as we discussed, for cells to, again, it will the Na plus Na sodium potassium pump will make sodium and potassium to transport to the original state. So இதுக்கு முன்னாடி இருந்த மாதிரி original condition move பண்றதுக்கு எடுத்துக்கிற period தான் refractory period. Very small time taken to transport K plus and Na plus. So this is called as refractory period. So if you give a strong stimulus also, your cell will not respond here. Okay, and after that we have a relative refractory period. So this is relative refractory period where you give more stimulus. So here more stimulus is required. If you give more stimulus only, your second next pulse, next stimulus happens, and again next repolarization, depolarization, like that it will continue. So this is called as action potential. So the maximum peak where your cell takes to convert from depolarization to repolarization phase is called as action potential. Most probably it will be around 30 to 40 millivolt. Millivolt, and 35 is normal. 35 millivolt is the time taken for maximum peak of action potential. Fine. So for sodium pump, we require for sodium pump, how much energy is required to stimulate for sodium pump? For potassium pump and sodium pump, how much energy is required? For ion channel,
minus 55.
yes, minus 55 is for sodium, and plus 40 or 35 is for potassium. Right? Fine. So understood. So we'll move on to next. Yeah, this is the overall summary of what we have discussed now. So this is first phase where your depolarization happens. Okay, so sorry, this is not depolar. Yeah, so this green cells, your green color cells are like sodium ions. So these green cells are sodium ions, and purple are potassium. So this is not depolarization, this is resting state. Correct பண்ற depolarization அமைதியா இருக்கியே. Okay, so here more potassium will be there in intracellular, sodium will be there in extracellular. So second phase is depolarization phase, where your green cells, your potassium, sodium cells will start through sodium pump. So this is green is sodium pump, purple is potassium pump, and red is sodium potassium pump. Okay, so simple. So sodium pump opens and all your Na plus ions moves, and your depolarization will end when it reaches 35 millivolt. So third phase is repolarization phase, where your like potassium ions, potassium gate opens, when intracellular potassium will move to extracellular, during that time your Na plus ions, but sodium ions, sodium pump will close. It will not allow the excess amount of sodium present in the extracellular. Some equilibrium on it will starts to close. Obviously, the potassium transport happens, and fourth stage is refractory stage, where Na plus K plus pump will activate. This is sodium potassium pump, and this is potassium pump. Okay, so this happens for one cycle. So this is the graph for one stimulus. It will continue till, if you give more stimulus, the same action potential curve will continue for longer period of time. So each heart, each and every second, this entire circle will keep on activating. So then only you can receive ECG signal. Okay, so depolarization நடக்கும், repolarization, refractory period. மறுபடியும் வந்து which in your heart where this stimulus happens. Okay, electrode வச்சு நம்ம வந்து ஒரு ECG எடுக்கிறதுக்கு ஸ்டிமுலஸ் கொடுக்குறோம். நேச்சுரலா ஹார்ட்ல எப்படி இந்த ஸ்டிமுலஸ் நடக்கும்? How these gates are getting open? In resting state la irundhu eppadi, if you give stimulus only, where depolarization happens, right? In heart, how depolarization, which is responsible
SCA
for
node,
giving?
sir.
Exactly. So sino-arterial node. So this is a natural stimulator in heart. SA node will give stimulus. If SA node fails, then only you will get ventricular fibrillation, apnea, tachycardia, bradycardia. When your SA nodes fails to do depolarization, the gate open pannala abdina, definitely there will be a difficult, all the life-threatening diseases, disorders happens in the heart. This is same for all other organs, brain, kidney, whatever it is. இப்ப புரியுதா எப்படி நம்ம நேச்சுரலா நம்மளோட ஹார்ட் பம்ப் ஆகுதுன்னு? Every muscle, every tissue, every cell you take, this happens. Fine, shall we proceed?
Yes, sir.
Yeah, this
Yes,
is
sir.
overall summary. You can go through like how this happened and all. So time, they have given a threshold and they have given a time duration for each. Okay, until now we have discussed different types of ion channels. How many ion channels are there? How many ion channels are there? How much? 3, right? What are they? 3?
Sodium, sir.
Is sodium ion channel.
Potassium ion channel and sodium potassium ion channel, sir.
Exactly. So fine. So what is the answer for second question? Different types of membrane transport.
Active membrane transport and passive membrane transport, sir.
This active and the passive. So now tell me which is active, which is passive. Example for active transport, example for passive transport. Active transport, if you give some energy only, your cell will pass through, right? So through sodium potassium ions. So your ion exchange, body ion exchange நடக்குது இல்லையா? Exchange. So this is the example of active transport. So passive transport is Veeresh have highlighted some. Initially, you have highlighted some points, right? So what is passive? You have given some answers during the starting of the class.
Diffusion and osmosis.
Osmosis. So simple, in your home, if you have a RO water, so simple water reverse osmosis happens. So this is passive. It doesn't require energy, right? So நம்மளோட ROக்கு உள்ள இருக்கிற அந்த மெம்பரேனுக்கு நீங்க ஏதாவது பவர் சப்ளை கொடுக்குறீங்களா? இல்ல. So automatically higher concentration la இருக்கிற அந்த particles lower concentration போது, so the equilibrium வருது, the purification process நடக்குது. That is reverse osmosis. It doesn't require any power. Simple. Fine. And the same way you can say diffusion. and facilitated diffusion. All those things, it doesn't require any power. Okay, so this is for passive transfer. Okay, what are the different application of Nernst potential? So we come to Nernst potential or Nernst equation, one of the important thing in our biomedical instrumentation. So what is Nernst potential? Like you can do some modeling. For example, இப்போ நம்ம வந்து ஒரு ஹைப்போதெட்டிக்கலா விஷுவலைஸ் பண்றோம். அப்படியே நீங்க ரியல் டைம்ல ஒரு மாடல் பண்ணோம். Okay, your ion exchange modeling, you can use this Nernst equation and you can do modeling, right? And you can do electrode designing, electrode validation. Or electrode design but அதை validate எப்படி பண்ணுவாங்கன்னா by using a Nernst equation. And corrosion testing. So for all these applications we can use Nernst potential. Fine, right? You answer this question. What is the answer for this? I need somebody new. I don't want repeating answers from same. Saumya, Kavyashree, Priyadarshini M, Subiksha, Bharati Ramamani, Sneha, Kannan, Vinosha, Emma, Vichitarani. So you people's anybody can answer. Sorry that I missed some names and I'm sorry that if you're answering, I am repeating your names, please back. Okay, like any call out names, whether you state that whether the first condition is correct or wrong. Which of the following is incorrect? So you need to pick the incorrect statement. You need to leave the correct statement and you need to pick incorrect statement. What is statement 1? Guys, yarum interest illa. Okay, fine.
So
You can
during the
go through
state,
this.
the membrane potential is positive.
Yeah, who is that?
Bharati's.
Bharati Ramamani. Yes. Yeah, Bharati. First statement, whether it is wrong or right. So during the resting state, membrane potential is positive. Membrane potential is positive. You can look into this action potential. So this is resting state, right?
Yes, sir.
So in resting state, your membrane potential is positive. Whether the statement is right or wrong. If wrong, why? If right, why? Membrane potential positive or negative? Resting state la. Which is membrane potential?
So, because it's minus 70 millivolt.
This is membrane potential.
So
Yes.
inside
So minus
will be
70, minus 70 plus 35. This is the membrane potential. The current required to activate. This is your membrane is called as membrane. So resting state it is minus 70, but they have given us positive. So this statement is
it's incorrect, sir.
it is incorrect. Okay, so I can in a given answer what will be the I can by if you identify this easily you can pick the answer, right? What's the answer for the given thing? A, B, C, D. Which is the correct answer?
Option B, sir.
Option
B, sir. Ball.
Option A, sir.
this one.
Yes, sir.
Option A or B?
A, sir.
A, sir.
Yes, sir.
Yeah, first statement
Because
is wrong,
it's
right?
correct,
So
sir.
obviously B have 2, 1, 6. So we don't have 1. And C also it have 2 and 5. And D also it have 4 and 5. So in gate, you don't need to verify all 6. If you find, you should be like not only in gate. So when you are appearing for placements also it appears. It applies. So நீங்க first statement incorrect னு முடிவு பண்ணிட்டீங்க. ஆப்ஷன்ல இது மட்டும் தான் ஃபர்ஸ்ட்ல இருக்கு. So obviously all others are wrong. Okay, you can pick easily. But we'll verify once again. We take 2. What they say is, during resting state, the cell membrane is polarized. Obviously, it is polarized. Okay, so this statement is correct. During depolarization, your sodium ions diffuses out of the cell. Okay, so your sodium ions will, during depolarization, outside of the cell diffuse. Diffuse na, it will go from outside of the cell to inside of the cell. Obviously, so this is correct, right? This is whether it is correct or wrong. Diffuses mean it's
It's wrong,
coming.
sir.
Yeah, it's coming out of the cell. But what is correct statement? In depolarization, your sodium ions moves from intra to extra, not from extra to intra. They told that outside of the cell diffuse inside of the cell, but it is vice versa. So this is wrong. Fourth statement, during resting state, intracellular region have more K plus ions. Definitely, I think so. This is correct from this statement. So intracellular have, we have more potassiums here. So obviously, the statement 4 is right. What is statement 5? Difference between extracellular and intracellular is called as membrane potential. Yeah, this is the definition for membrane potential. But so there was small change here. Intracellular inge varano, extracellular inge varano. So the difference between intracellular and the extracellular is called as membrane potential. Fine. Intra minus extra. Okay. E I minus E out. This is called as membrane potential. So this is right. Fine. We'll leave that, but definition is okay. But okay, what is 6th? During resting state, extracellular potential is 0. Obviously, whether this is correct. Extracellular potential. So potential is 0. Both extracellular is 0 and intracellular is also 0. So this is also correct. So statement 1, statement 3 are wrong answers. So obviously A is the right answer.
Sir,
Yeah.
sir, during resting stage, the intracellular potential would be minus 70 millivolts now, sir.
Yeah, that is membrane potential. Potential is different. The potential is nothing but so here if I apply some stimulus, right? So this I need to apply some stimulus here. So that is called potential. Potential அப்படின்னா minus 70 millivolt வரைக்கும் இது இப்போ ஃபார் எக்ஸாம்பிள் -55 நீ அப்ளை ஆனாதான் உன்னோட இன்ட்ராசெல்லுலர் எக்ஸ்ட்ராசெல்லுலர் இந்த அயன் டிரான்ஸ்போர்ட் நடக்கும். அதுக்கு கீழே பாத்தீங்கன்னா இட் இஸ் 0. அதாவது என்ன சொல்ல வராங்கன்னா மெம்பரேன் பொட்டன்ஷியல் இஸ் டிஃபரெண்ட் ஃப்ரம் பொட்டன்ஷியல். ஹியர் லைக் ஸோ இந்த டிரான்ஸ்போர்ட் நடக்கல இல்லையா, ஸோ தேர் இஸ் 0 பொட்டன்ஷியல் ஓவர் தேர். இன் யுவர் சார்ஜ் செப்பரேஷன் 0 ion concentration will be there for extracellular sodium and intracellular potassium. Only when you give some small -55 millivolt or some stimulus, it starts to move. But initially the membrane potential is in the entire membrane. If you take if you analyze, your potential will be like membrane potential is -77, but if you measure the current, it is 0. There is no ion transport. Only ion transport. Ion transport நடக்கும்போது தான் இந்த பொட்டன்ஷியல் கிரியேட் ஆகும். அயன் டிரான்ஸ்போர்ட் நடக்கலன்னா பொட்டன்ஷியல் கிரியேட் ஆகாது. இட் இஸ் 0. Fine. Difference between membrane potential. Yeah, this is good question. Fine. So qualitative analysis for NADs, we have a Nernst equation, we have Donan equation. For we going to move towards numerical part here, and we have K plus ions, we have potassium, sodium, and chloride. So we have studied 3 ions, right? So potassium, sodium, and chloride. இப்போ நம்ம ஜெனரிக்கா இப்போ கேட் பெர்ஸ்பெக்டிவ்ல நம்ம பார்க்க போறோம். இப்போ உங்களோட கொஸ்டின்ல ஓகே, நீங்க உங்களுக்கு கொடுத்திருக்கிற கொஸ்டின்ல ஒரே ஒரு அயான், நாட் only K plus, they can give Cl minus Na plus whatever it is. If they give only one ion, And if they ask you to find some membrane potential or some potential, so we need to follow a Nernst equation. So there are three equations for each case. So this is case 1, this is case 2, this is case 3. So Nernst equation for sodium. இப்போ ரெண்டு அயான்ஸ் கொடுத்துருக்காங்க. உன்னோட கொஸ்டின்ல ரெண்டு அயான்ஸ் இருக்கு. சோடியம் ஒன்று, பொட்டாசியம் ஒன்று, கால்சியம் ஒன்று. அப்போ இதை வந்து நீங்க சால்வ் பண்றதுக்கு யூ நீட் டு டூ அ டோனன் ஈக்குவேஷன். யூ ஹேவ் டு கோ ஃபார், யூ ஹேவ் டு ரீகால் டோனன் ஈக்குவலிபிரியம் equation. Okay, you can here this is only one ions. It is very easy to find by using Nernst equation. I am going to add one layer of complexity here. So I am going to add one more ions. So little bit complex, and two ions are permeable, K plus and Cl minus. You can solve this by using Donan equilibrium. And I am adding one more complexity layer here. So I have had three ions, and three ions are permeable. So K plus ions, Na plus and Cl minus, all three are permeable. For this, I can use Boltzmann equation. Equations for three different conditions. Questionல ஒரு அயான்னா Nernst equation வச்சு கண்டுபிடி, ரெண்டு அயான்னா Donan equation, மூணு அயான்னா Boltzmann. So in the moon equation, if you remember, analyzing and answering NAT for membrane potential is very simple. It's very easy. Fine. Shall we move on to NATs?
Yes, sir.
So before that, we should understand what is Nernst equation, what is Donan equation, what is Boltzmann equation. Okay. So for that, I'll have. I don't want to waste time in writing equations. I have a summary here. So this is the summary of different part of equations. For this is condition 1, this is condition 2, and this is condition 3. So here only one ion present. Okay, so single permeable application, single permeable ion. So this may be K plus alone, or Na plus alone, or Cl minus alone. Only one cell permeable. அதாவது கேட் வந்து ஒரு சேனல் மட்டும் ஓபன் ஆயிருக்கும் போது அதுல வந்து மெம்பரின் பொட்டன்ஷியல் கண்டுபிடிக்க சொல்லுவாங்க. ஓகே, அதுக்கு வந்து you can use Nernst potential. So Nernst potential is one of the most important question. You should recall it for gate, not only for gate, for Anna University also. We may expect problems from Nernst equation. Okay, so try to solve some problems here from Nernst equation. So this happens in resting potential, to modeling resting potential, and you can apply yourself and you can find answers. So this is the we have studied, right? So the intracellular minus extracellular, this is membrane potential. Calculate membrane potential. So we have minus RT by ZF ln of Ci by C0. What is R? What is T? What is Z? What is F? R. R is a gas constant, right? R is a gas constant. T is body temperature in Kelvin. So it is 37 degree, but if you want to add up 37 degree with 272, it converted into Kelvin. So T is temperature, body temperature. R is gas constant. Approximately this is 8.34, and this is, you can add 37 with 272. And what is Z? Any atom, if you take, what is Z? Valence, right? So valence, yeah, atomic number, valence band, atomic number of the atom. What is F?
Faraday's constant.
Faraday's constant, right? And what is Ca and Co? This is concentration of ion. So this is concentration of intracellular ion. This is concentration of extracellular ion. For all this, we have so if we solve this, part, I have all these are like constants, right? So gas constant நமக்கு முன்னாடியே வேல்யூ தெரியும். Temperature, it is room body temperature 37 degree. Faraday's constant எனக்கு தெரியும். Valence மட்டும் மாறும். For example, Na plus K plus Cl minus க்கு மாறும். So Na plus you have one ion, one valence is 1, but K plus 1, Cl is minus 1, cation, calcium is 2. Okay, if they ask calcium only, you have to change this value. Calcium and chloride. So it is minus 1 and 2. But for sodium and potassium, you can have 1 and you can solve this. If I solve this, I'll have some values. So it is minus 26.17 millivolt. You can note it down. So you, if they'll give lot of values and they'll confuse you. Okay, so please don't fall into trap. So don't waste time in solving this. Okay, so if you solve this, all are constant. Minus 27, minus 26.17, this value you should recall. Okay, இல்ல என்னால ரீகால்லாம் பண்ண முடியாதுன்னா they'll give all the values, you can solve by your own. பண்ணீங்கன்னா இந்த வேல்யூ கண்டிப்பா வரும். More or less equal ஆகும். Fine. So this is for single permeable membrane. So two permeable membrane, either K plus and Na minus, sorry, K plus and Na plus, like that, or K plus and Cl minus, you will have this Donan equation. This is Donan equation. So by solving this, you can find answer. Simple, it's very simple. So 4 values they'll give, you can just substitute and find the answer. Many permeable membrane, more than two ions. I have calcium, potassium, and chloride, and like calcium and all. You can have more permeable membrane for Goldsman. So the equation name is Goldsman equation. You can follow this. So this equation. Okay, and here, like so in Goldsman equation, P is nothing but permittivity. They'll give permittivity, they'll give inside outside membrane potentials and all. Just you substitute it and solve it. அதே போல இங்கேயும் வந்து we have values to solve this. I tell you what values is when you solve any. Right. So each one equation, I solve one example. You try in your home by solving more problems. Okay, fine. So this is gate BM gate 2020 question. Okay, so நீங்க நம்ப மாட்டீங்க, பிஎம் 2020ல மட்டும் கேட்ல இந்த மெம்பரின் பொட்டன்ஷியல் இருந்த மட்டும் யூ கெட் 10 11 தெரியல 11 மார்க்ஸ். ஓகே, 11 மார்க்ஸ் ஒன்லி இன் மெம்பரின் பொட்டன்ஷியல். ஐ திங்க் மோர் ஆர் லெஸ் 11 நினைக்கிறேன், 9 11 எனக்கு கன்ஃபியூசிங் இருக்கு. பட் மோர் தென் 5 வச்சுக்கோங்களேன். ஸோ கெட் மோர் தென் 5 மார்க்ஸ் ஃப்ரம் இந்த கொஸ்டினும் வந்து இட் இஸ் ஃப்ரம் கேட் 2020. This is 1 mark question, this is 2 mark question. Okay, they give more weightage. So இந்த 11 மார்க் நீங்க வாங்கிட்டீங்கன்னா கேட்ல வந்து பாதி கிணறு தாண்ட மாதிரி. ஸோ the maximum கேட் கிளியர் பண்றதுக்கு வந்து மார்க் வந்து 24 நினைக்கிறேன் 2020ல. You get 24 marks, you can clear gate. அதுல 11 மார்க் மெம்பரின் பொட்டன்ஷியல் மட்டும். இது இல்லாம இன்னும் நிறைய டாபிக்ஸ் நான் பயோமெடிக்கல் இன்ஸ்ட்ருமெண்டேஷன்ல இருந்து கேட்டிருந்தேன். So you can give more weightage, right? So accordingly, fine. How to solve this? What approach I need to find? Either condition 1, 2, 3. What is the approach? So you can take this as first question, second question.
Donan
equation. Yeah, you just go by first question alone and second question alone. Not these two questions are not interrelated.
Using Nernst equation, sir.
Yeah, Nernst equation. Fine. So for first question, we have only sodium and we have only potassium. Right. So Nernst equation, we write Nernst equation minus RT by ZF ln of concentration of intracellular fluid by concentration of extracellular, outside by inside. Okay. So if I solve this, I'll get minus 26.17. Okay. So I get minus 26.17, and so this implies to like membrane potential of what? If it is first case, it is Na plus. This is membrane potential of Na plus. This is the equation for Nernst equation. Just substitute it and find answer. Okay, so this is the value which I know already. So for Na plus, I'll solve membrane potential for Na plus is nothing but minus 26.17 ln of what is intracellular? What is intracellular?
14.
These units you can leave that. So it's molar per equivalent per liters. So we have 14 as intracellular by outside the cell is 142. What is the answer here? Closer to answer which given here. What answer you get for this particular thing? And I solve it for
60.
potassium. 60 point
60.62, sir.
62. Whether it is minus or plus?
Plus, sir.
Plus. Okay. So this is approximately, you can approximate it around 61.9 because they are 26.17 in some case, like there may be some small deviation, but you can relate with answers. Okay, if it is NAT, definitely they'll give ranges. So if you give a range from 60 to 61.9, they'll give range. Okay, so fine. This is plus 61.9, and what is A plus minus 26.17 ln of what is the value here? சொல்லுங்கப்பா, டைம் ஆச்சு.
140/4, sir.
140 by 4. So can you quick calculate it and tell me what is the answer here?
Minus 93.04, sir.
93.04, and you approximate it to your answer, it is around minus 94.9. So this is first answer, this is second answer. So what is the option here? Option C, right? So minus,
Yes, sir.
sorry, your Na plus is 61.9 and your K plus sodium is minus 94.9. So very simple, right? So the Nernst equation looks very complicated. Definitely your faculties will make this equation very tougher. Don't worry, it is very, very easy equation if you remember the concept. Okay, only thing is you should able to remember the what is R, what is T, Z and F and R. Don't calculate it. So if you calculate it, definitely it will give a lot of, it will take a lot of time. Okay, so most probably the generic in most of the books they'll give 26.17 is the constant value. You can directly put it and you can find answers. Right? Any doubts in this particular question? Any doubt? Clarifications on this question? Shall we move on? Is in this question you see like gas constant கொடுத்திருக்கான், temperature கொடுத்திருக்கான், Faraday's constant கொடுத்திருக்கான். ஸோ இதெல்லாம் வச்சு நீங்க வந்து ஆர்டி பை இசட்எஃப் சால்வ் பண்ணீங்கன்னா எகெயின் அது வந்து ஒரு பெரிய ப்ராப்ளமா போகும். ஸோ ப்ளீஸ் டோன்ட் சால்வ் இட், டைரக்ட்லி கோ ஃபார் தி ஆன்சர். ஓகே, இதுவும் வந்து இட் இஸ் பிஎம் கேட் 2020 கொஸ்டின். ஸோ திஸ் இஸ் 2 mark. They give 2 mark for this, right? ஸோ என்ன சொல்றாங்க அப்படின்னா in this question they are inserting administrating a drug. So they give some, you take some anesthesia drug or any drug, insulin, whatever it is. The doctor வந்து ஒரு பேஷண்ட்டுக்கு இந்த பாடியில, ஒரு பேஷண்ட்ஸ் பாடியில they give some drug, ஒரு ட்ரக் வந்து உள்ள அட்மினிஸ்ட்ரேட் பண்றாங்க. ஓகே, ஸோ இன்னும் மேமல்லன் நர்வ் டிஷ்யூ, ஸோ ஒரு மேமல்லனுக்கு ஒரு மேமலியன் டிஷ்யூக்கு வந்து பண்றாங்க. ஓகே, அப்போ பிஃபோர் அட்மினிஸ்ட்ரேட்டிங், okay, உன்னோடைய resting potential is minus 80 millivolt. Okay, after administrating drug உள்ள செலுத்தினதுக்கு அப்புறம், after administrating a drug, they ask you to find what is the cell membrane potential after. Okay, after the drug administration. This is before. Minus 80 millivolt is before. Okay, so what is the definition for membrane potential? is the definition.
between intracellular and extracellular.
Yes, exactly. So difference between intracellular and extracellular. Okay, this will gives you some like what you say, like RT by ZF. You have minus here, ln of concentration inside by concentration outside. So this is Nernst equation. Just to supply, we have given EI, they are given as minus 80 millivolt, and RT by ZF we know minus 26.17, and they have given like your body changes the intracellular K plus concentration from 150 millivolt to 55 millivolt, right? So your I'll write it here. Your potassium intracellular. Okay, so intracellular இருந்து change ஆகுது எவ்வளோ அப்படின்னா, it is first we have 150 okay, millimoles per liter, something else, and your potassium outside, if it is transporting to outside, you have what to say, like it is 55 okay, millimoles per deciliter after administrating a drug. Okay, so this is before, this is after, and they say that K plus doesn't change. So உன்னோட drug pass பண்றதுக்கு முன்னாடி அதுதான், pass பண்ணதுக்கு அப்புறமும் அதே தான் சொல்லிட்டான். So we have two equations to solve. Okay, I'll write down in this slide. We have two equations. ஒன்னு வந்து பாத்தீங்கன்னா, drug போடுறதுக்கு முன்னாடி, ஒரு drug வந்து செலுத்துறதுக்கு முன்னாடி உன்னோட ஈக்குவேஷன், நர்ஸ்ட் ஈக்குவேஷன் எப்படி இருக்கும், உன்னோட மெம்பரேன் பொட்டன்ஷியல் minus 18 சொல்லிட்டான். ஓகே, இதை நான் வந்து அப்படியே எழுதிக்கிறேன், 26.17 RT by ZF. உன்னோட ln intracellular by extracellular, உன்னோட intracellular K plus ions வந்து எவ்வளோ அப்படின்னா 150. எக்ஸ்ட்ராசெல்லுலர் வந்து will have as it is. So CO அது அப்படியே சேஞ்ச் ஆகல அப்படின்னு வச்சிருக்கோம். இது அப்படியே it is considered as equation number. செகண்ட் ஈக்குவேஷன் நமக்கு வந்து என்ன கண்டுபிடிச்சு சொல்லியிருக்கான், எக்ஸ்ட்ராசெல்லுலர் அவுட்சைட் தி செல்லோடைய மெம்பரேன் பொட்டன்ஷியல் கேட்கலாம். ஆஃப்டர் ப்ரோட்டீன் டசன்ட் லைக் they changed. So what membrane potential is changing? So அதுதான் கேட்குறான் எக்ஸ்ட்ராசெல்லுலர் ஃபியர்ல. ஸோ நமக்கு தெரியாது, ஸோ அதுதான் கண்டுபிடிக்கணும். இதுக்கு வந்து அதே minus 26.17 ln of I have இங்க வந்து after administrating is we have 50. இது வந்து K plus மாறல, so I take it as it is. So this equation is for before, this is for after. Okay, you keep right hand side as it is, just divide the ln part because இது ரெண்டுமே ஈக்குவலா இருக்கு, so I can take the common as it is. இதை மட்டும் நான் வந்து டிவைட் பண்ணனா these two will cancel, and the membrane potential definition is minus 80 minus your extracellular. This is your definition of membrane potential. This will make into minus 26.17 அப்படியே வச்சுக்கோங்க. Just do the internal rewriting this equation. I have ln of 150 by solving it. What will be the answer? Quickly solve and tell me. So to right hand part alone. The answer here. Obviously the answer will be minus. Just put ln of 150 by 50 and just multiply with minus 26.1.
Minus 26.25.
Right. So I want to find this side. So this membrane potential. So I'll bring this membrane potential of outside the cell to this side. And I'll bring 26.25 that side. So I have minus 80 plus 26.25. So what is the answer?
$53.75.
3 point what?
756.
75. So this is your membrane potential. Okay, so we have 3.75 minus millivolt. Very simple calculation. Just you apply your mindset. The outside cell, inside cell, drug போடுறாங்க. அது ஒரு சின்ன trap. Drug administrationக்கு முன்னாடி பின்னாடி போடுற அந்த trap மட்டும் தான். நிறைய பேர் என்ன பண்ணிடுவீங்க, இந்த இடத்துல வந்து -80 அப்படியே வச்சுக்குவீங்க இந்த சப்ராக்ஷன் பண்ணாம. ஸோ அப்படி போடும்போது இந்த மைனஸ் இந்த பக்கம் வரும்போது இந்த இடம் பிளஸ் ஆயிடும். ஸோ அந்த ஒரே ஒரு ட்ராப்ல தான் எல்லாரும் மாட்டோம். மற்றபடி எல்லாமே இட் இஸ் வெரி சிம்பிள். மோஸ்ட் ப்ராபப்லி இந்த மாதிரி கொஸ்டின் வந்தா ரெண்டு எக்ஸ்ட்ரா செல்லர் இன்ட்ரெஸ்ட்ல 150 55 கொடுத்துருப்பாங்க. ஜஸ்ட் யூ டிவைட் இட் அண்ட் ஃபைண்ட் தி லான் அண்ட் தென் யூ மல்டிப்ளை வித் -26.17. இந்த சைடு வந்து இட் இஸ் வெரி ஈஸி. திஸ் சைடு இஸ் ஈஸி. ஒன்லி காம்ப்ளிகேட்டட் திங் இஸ் ரைட் லெஃப்ட் சைட். ஸோ இதை வந்து கரெக்டா பண்ணிட்டீங்கன்னா ஆன்சர் வில் பி கரெக்ட். ஓகே, ஸோ இஃப் யூ ஈவன் இஃப் யூ புட் பிளஸ் இன்ஸ்டெட் ஆஃப் மைனஸ் ஹியர், your answer will be wrong. Okay, so in gate minus na neenga minus nu type பண்ணனும். அப்பதான் வந்து your answer will be right. Fine. So this is the second part of our class. Second part of our condition. So what is the approach to solve this particular question? Quick answers. Guys, are you there? Am I audible?
A simple last equation.
What equation? Donan equation, right? So you can solve by using Donan equation. So they have given two cells, intracellular K plus. Okay, K plus is 150 into 10 to the power of -6, and extracellular K plus is 6 into 10 to the power of -6.
Sir,
Okay.
doubt, sir.
Yes.
சார் இங்க ஏன் சார் டோனான் ஈக்குவேஷன் யூஸ் பண்றோம், நர்ஸ்ட் ஈக்குவேஷன் யூஸ் பண்ணலாம் தானே சார்?
Yeah, question was wrong. Na plus, not K plus. Now okay, fine.
Yeah,
Is that
yes, sir.
fine?
Okay, sir. Yes,
Question
sir.
was wrongly typed. Okay, so we have extracellular Na plus ions as 6 into 10 to the power of -6. So simple, just do some calculations and find the answer. If it is in some சார் வந்து நிறைய அந்த உங்களோட மார்க் இன்டர்வியூல இது மாதிரி ட்ராப்ஸ் நிறைய வைப்பாரு. ஸோ அதை பார்த்து நான் கொஸ்டின் எடுத்ததுனால இப்படி இருக்கு. ஸோ ஒரு மார்க் டெஸ்ட்ல என்ன கேட்டிருந்தாரு, இன்ஸ்டெட் ஆஃப் Na plus they ask K plus. So if it is K plus, what is the approach?
Nernst equation, sir.
Yes, Nernst equation. Okay, so you can solve it and we find the answer. And this part, this question, what is the approach to solve this question?
Using Goldman equation, sir, because 3 different ions.
Yeah, we have K plus Na plus Cl minus. We can solve it by using Goldman's. Goldman is Nobel Prize winner. So they named the equation behind his name. So our name in the equation is. Okay, so Goldman equation is, we want to membrane potential கண்டுபிடிக்கணும் அப்படின்னா we have RT by F. We don't have Z here because we have 3 different ions, so we don't have Z here. And ln of permittivity. So here I have K plus Na plus Cl minus. So I have right in that terminology. Permittivity of K plus into K plus ions in outside. Okay, plus permittivity of Na plus into the extracellular membrane potential of Na plus in outside. Okay, plus permittivity of Cl minus into Cl minus. This is inside. Okay, this divided by சேம் இது அப்படியே ரிப்பீட் ஆகணும். permittivity k plus இங்க அவுட் சைடு இருக்கு, ஸோ இங்க வந்து will have inside. Very easy to recall. Permittivity of Na plus inside, and here you have permittivity of Cl minus outside. So we have inside here, we have outside. Very simple. Like so, the same way if you manipulate it, again all these things are constants. So Faraday's constant, temperature, and other constants. If you calculate this, the value which I have is like 239.54. This is a constant value. Okay, they have given R and Faraday's constant. It just substitute and find the answer. They have given, but simple like இங்க வந்து என்ன சொல்லிருக்காங்க 3.6 சொல்லிருக்காங்க. If it is room temperature, there will be a different answer. Since it is 3.6, you have to do some small back foot here. You just add this 3.6 plus 272. You convert it into Kelvin, and then you substitute here. So T அப்படியே 3.6 ன்னு substitute பண்ணீங்கன்னா answer is wrong. Okay, so keep in mind 3.6 degree Celsius எங்க கேட்ல வந்தாலும் டெம்பரேச்சர் வந்தா நீங்க கண்டிப்பா கெல்வினா மாத்திட்டு தான் அதை சால்வ் பண்ணணும். சரிங்களா? keep in mind. Okay, if I solve this, I have 239.54. So I take it that the same 239.54, and I have a ln here, and I have what is permeability of potassium, and just multiply and tell me very fast. So this is permittivity, and this is your cytoplasm at intracellular, and this is extracellular. Okay, this is inside, this is outside. Just multiplication. Quick. என்னையா சொல்லுங்க. What is permittivity of K plus ion?
So 1 into 20.
So 1 into 20 plus அப்புறம் what is sodium?
0.04 into
2.04 into 440. Somebody put it into calculator and tell me the answer simultaneously. What is Cl minus 0.45 into 52, right? This divided by 1 into 400. Nobody will support me. அவனே காலையில இருந்து கிளாஸ்ல கத்திட்டு வரான், இங்கேயும் சாப்பிட்டு விட்டுருங்க. யாரா சப்போர்ட் பண்றியா சொல்லு பார்க்கலாம். இன்ட்ரெஸ்டிங்கா எனக்கும் இருக்கும்ல, நீயும் சொன்னீங்கன்னா ஏதோ வந்து fine. Up to you then. Okay, if you solve this, what will be the answer?
Sir, numerator 61.
Sorry?
61, sir, numerator.
Final answer, huh?
Yes, sir, numerator.
Okay. Numerator is what? 61.
61, sir.
Okay, what is denominator?
by 4, sir.
By 4. Okay, take a ln and tell me. If I take a ln, the value, if you divide this, the value will be 0.0932. If ln edutona, I have minus la varudho answer.
Minus 2.37.
2.37. 373 into 10 to the power of what? 4. You see in calculator will have 10 to the power of 4. Okay, so you just take, we don't have ln here. You need to convert it into millivolt because the answer should be in millivolt. You just multiply this answer with 10 to the power of minus 3 you will get the final value as minus 56.8 millivolt. Okay, so here the answer is 56.8. Just do that and find whether you receive this answer or not.
Yes, sir.
All of you got this answer?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So with this, we'll wind up membrane potential. Any doubts before we go in? Other two topics are very lighter. You have studied a lot about pH and all. I don't want to spend much time. Another 5 minutes will complete the class. Most probably by 8:30. Okay. Before we wind up membrane potential, what is the feedback? Whether you have feel some difference between a regular class and gate class? The same membrane potential, same action potential, but we have discussed in a different perspective, right?
Yes, sir.
Any college they have teach you this this much deep nurse equation solving questions, Donan?
Last time you have taught us, sir.
Last year in which
During
subject?
our serial test,
You are
sir.
test you have taught us, sir.
Oh, fine. That's fine. But it should be it's nice to learn deeper. Like you can do modeling, you can do projects. A lot of projects can be taken over through this nurse equation and all. You can design your own. You can stimulate your own blocks in LabVIEW and other simulating softwares. You give some membrane potential for K plus, and you can see what output is. You can give some intracellular level, extracellular level. You can see like in which space your heart attack, ventricular fibrillation எப்போ வரும்ன்றது கூட வந்து நீங்க இதுல மாடலிங்ல ப்ரெடிக்ட் பண்ண முடியும். சரியா? ஸோ நீங்க ரொம்ப மினிமலா K plus அந்த அயான் டிரான்ஸ்போர்ட் நடக்குது 0 அதெல்லாம் கொடுத்தீங்கன்னா you will have a different answers. We have normal answers and abnormal answers. So definitely ventricular fibrillation, definitely nurse equation எடுத்தீங்கன்னா அந்த பேஷண்டோட nurse equation will be in abnormal mode. So that's why they get they are not making their essay notes stimulus. Obviously in the ion transport நடக்காது. சரியா? Fine. So quickly we'll complete the remaining part. So we have pH in GATE 2021 BM 2021. One of the very easiest question in GATE BM 2021 is, those who are appeared for BM 2021, can you remember the question? Which is the easiest question in GATE 2021 BM? நிறைய பேர் அப்ளை பண்ணீங்களே, சிந்துஜா, ஏஞ்சலின், அப்புறம் யார் இருக்கீங்க? Those who are appeared for GATE last year. ஞாபகம் இல்லையா? Okay. They have easiest question. கண்டிப்பா ஒரு 2-3 question அது மாதிரி இருக்கும். One of the very easiest question in overall paper is, they ask you what is the pH of blood. What is pH of blood?
7.2.
7.2. No.
7.3.
7.3. Exactly what there is some range.
1.35.
Yes. So it's 7.35 to 7.45. So this is your normal range. Fine. So pH you have studied a lot again. You have studied in chemistry, biochemistry, அதுக்கப்புறம் in your +2, அப்புறம் biomedical instrumentation, even anatomy, அதுக்கப்புறம் என்னது biomedical instrumentation, அப்புறம் DTE. You have done in laboratory also. So a lot of times you have studied this. So simply if you want to recall the construction part, so we have reference electrode at one part and measuring electrode at one side. So measuring reference electrode will be most probably it is 0. Why 0 is, so if you இந்த எலக்ட்ரோட் வந்து ஒரு லிக்விட் ஒரு மீடியம் ஒரு லிக்விட் மீடியம்ல சிங்க் பண்ணீங்கன்னா இங்க இருக்கிற அந்த அயான்ஸ் வந்து இந்த சால்ட் பாண்டேஜ் வந்து இதுக்குள்ள போக அலோ பண்ணாது, because it is freezed, so it is 0. Okay, so this will not allow your solutionல இருக்கிற அந்த அயான்ஸ் வந்து இந்த எலக்ட்ரோடுக்குள்ள வந்து போகாது. சரியா? இந்த எலக்ட்ரோலைட் சொல்யூஷன், so it is 0. Measuring electrode, obviously there will be a ion exchange happens. So there will be interactions happens. So based on the ion concentration, your electrode will measure. So these measuring electrode will compare with voltmeter. So with the 0, and it will give you some results. So this is pH results. What is the unit of pH? What is the unit of pH? Shweta is there. What is unit of pH, ma? pH unit.
Yes, I guess.
Sir, I guess it has no unit, sir, because of the algorithm.
Very good. So pH doesn't have unit. We all should be able to recall this. pH doesn't have unit. Okay. So this is how the pH is measured, and we have some pH formula to calculate. The Nernst equation is similar. So by using that, you can calculate pH. So they'll give you hydrogen ion concentration, and they'll give permittivity of hydrogen ion. You just substitute it and find answer. Okay, what is the valence of pH? Sorry, what is the valence of H plus ion? It is 1, right? So you will have received the same result. If you solve this, you will get minus 26.1. So just substitute it and find answer. Okay, we have some ranges. Okay, so we'll draw a line. So we'll have some ranges. So what is the neutral range of pH?
7.
7. So this is neutral. Okay. So greater than 7. What is this
Yes.
range called?
Base.
Base. Base. Otherwise, it is called what? Greater than 7. For example, if it is 10, 15. Base or
Alkaline.
greater than 7. Alkaline. Okay. Less than 7.
Acids.
Acids.
Acidic. Okay, it is acidic. So below 7. Most probably like even it go till minus 7. This is neutral and this is acidic. This is alkaline. Okay. Coming to answer this part, what is the pH of pure water? Distilled water, or you can say buffer. What is the pH of buffer? What is buffer solution? What is the definition of buffer solution?
7.
7. So if the pure water have buffer solution or pure water have a pH of 7, that is pure water. So if you have a water and if you calculate pH, it should be 7. That's pure water. If it is less than 7, greater than 7, according to your salt, you can have less than 7 and greater than 7. Right? What is pH of blood? It is 7.35 to 7.45, and so blood falls in which range? Whether it is neutral, acidic, alkaline, blood belongs to which category?
Slightly alkaline nature. Sir.
Yes. Who is that?
Shweta, sir.
Super, Shweta. It is slightly alkaline. Okay, it's slightly alkaline, and so it's nice to remember the values. Yeah, just to solve this and just find the answer. This is the same by using the previous Nernst equation. You can solve it. The only thing is the pH changes from 6 to 8. So you just multiply. Sorry, you just subtract it. 8 minus 6, you have 2. You just substitute the value in the final equation and find answer. So a shortcut to remember the formula is, so if you want to find the voltage, you just multiply the you want to find change in circuit. So change is nothing but some del E happens. So there will be an initial energy and there will be a change in voltage. So by solving this Nernst equation, okay, so solving this Next equation by substituting hydrogen ion for hydrogen ion is 2. So because here they have given 2 and the permittivity is they have given 1. Okay, I consider this as 1. So in the equation solve பண்ணனா I get a constant value as minus, sorry, not minus, 0.059. So pH it's nice to remember. So how to solve this? So you have a change in energy. You just multiply with your given pH value, okay, plus constant. Okay, your given pH value is 8 minus, that is changed from 8 to 6. So you just subtract it and you substitute the answer 0.59 into 2. Okay, so this constant we can skip this. Okay, we have 1.18 volt. Convert into millivolt, you will get 180 millivolt. Okay, voltage when the sorry, this is 8 to 6. So when the voltage of pH turns to 8 to 6, your final answer is this. Fine. So it's nice to learn this, and if you substitute in this equation also, you will get answer, the same answer. Okay, electrodes. So I don't want to spend much time in electrodes. It's very easy. So we have surface electrode. If the electrodes are placed in surface, like this is what electrode? Suction, right?
Suction.
So this one, metal plate. And what is this one? Again, this also one of the metal plate. And we have disposable electrode in the surface electrode category. Okay, so this is nice to learn, and we have very broad theory part in our unannounced syllabus. So you can definitely, this is one of the most important 13 mark question also. So definitely, I think so. You came across this topic a lot. Okay, needle electrode. It is an invasive technique. So invasive technique where you can insert a needle and you can record a biopotential from a muscle or something else. Most probably application of needle electrode either in EMG, EEG, they'll go for needle. And micro electrode, it is placed in the tip of any cell permanently or temporarily, and you can acquire a biosignals. And application, we have 3 electrodes: surface electrode, needle electrode, and micro electrode. So can anyone give one application for each category? I have
Surface electrode ECG indicator.
surface electrode, ECG, right? So
Yes.
example is ECG, EEG, and EMG and all will measure, but most probably ECG. And application where they use surface electrode, cardiology, right?
Yes.
And this surface electrode is made up of, what is AgCl?
Silver chloride, sir.
Yeah, silver chloride, silver and silver chloride. Okay, and next is we have yes, for infant monitoring. For infant monitoring, cardiology, and all, we'll have same thing. And needle electrode.
In neurology, use needle electrodes.
Exactly. So most probably they'll use in neurology for taking EEG, and mostly EMG signals, accurate EMG signals are recorded by using needle electrode. Right. So application to acquire a muscle activity, study a muscle activity. So sports person, those who are injured with hamstring injury, something else, you can do muscle activity test. Okay, and then you can find the answers. And third one is micro. So where micro electrode is used? for both EMG and EEG, just to do a intracardiac application is internally, heart or internal structures which you can use intracardiac probe. Okay, intracardiac probe, they use microelectrode over. Fine, right. So that's it about application part. And so this very small topic, which is there in our syllabus. Some questions may be there from electrodes also. It's nice to learn what is silver chloride, material of each electrodes. It's nice to learn, and equivalent circuits and all. So any questions, any queries? How is the class? I want to ask with newcomers from my own college, like Kopita, Shweta. How was the class? It's very new to you actually. Others. So can you give some comments, feedbacks?
Sir, I'm Shweta, sir. It was helpful for me to go back to what I learned, and I can remember all the points that I studied, but it was helping me to cope up with that now, and now I can relate it with the current subjects that I study, and it was helpful, sir. Helpful.
Fine. Okay. Fine. So others, any comments, any queries, questions?
Sobita.
Yeah, Sobita. Yes.
Yes, sir. It is very useful to gain more information about the active potentials, potential of.
Yeah. Thank you. And I think others, you'll be familiarized with topics, and so you can see some difference in your regular class with gate preparation and good learning and continued learning. Spend some time. So you have some holidays coming, so spend some time in solving questions. So we have mock test released. So take mock test and submit it before your puja holidays. Okay. So there are a lot of holidays coming. So kindly use the holidays for preparation for gate.